without them, it wouldn't be. Our speaker today for Space Settlements is Fred Scharmen, Associate AIA and Professor of Architecture and Urban Design at Morgan State University School of Architecture and Planning. He is the co-founder of the Working Group on Adaptive Systems, an art and design consultancy based in Baltimore, Maryland. His work as a designer and researcher is about how we imagine new spaces for future worlds and about who is invited into them. His first book, Space Settlements, is on NASA's 1970s proposal to construct large cities in space for millions of people. It is out now from Columbia Books on architecture and the city. He received his master's degree in architecture from Yale University, and his writing has been published in the Journal of Architecture Education, Blog, Clog, Volume, and Domus. His architectural criticism has appeared in the Architect's newspaper and in the local alt weekly Baltimore City paper. So right before I pass it to Fred, I would also like to remind you that if you need AIA or ASLA credits, there is a link in the Zoom group chat for you to fill out. And with that, off to Kathleen, or to Fred.
Okay, I think that's me now. Thank you very much, Margaret, for that introduction. And thank you to the AIA and to the BAF for the invitation to give this talk. You know, I've realized that I've been going to these AIA lectures, AIA Baltimore lectures, for over 10 years now. So it's really an honor to take part in one like this. I should also thank the Graham Foundation in Chicago, as well as the Dean's Office at my home institution, Morgan State University, for funding that contributed greatly to the viability of this research. This research in this book wouldn't have been possible without the help from those two institutions. So long may art and design research funding last in this strange new era we find ourselves in. So to contextualize things a little bit.
I'm gonna come sit with you.
Well, Jonathan. Hi, Jonathan. To contextualize things a little bit, this talk is about 5 years worth of directed research and the book that resulted from that work. And to sort of frame my work generally as a researcher, a teacher, and a designer, the working assumption that defines all of it is that there are no real hard boundaries between utopianism, space science, science fiction, and the spatial practices of landscape architecture, architecture, and urban design. That these fields really have more in common than they do in difference. My slides aren't advancing here. Hang on one second. Sorry about it. Let me try that again. Share. Okay. So that seems to be working now. This book's topic is a series of exercises done in the 1970s, partly under the auspices of NASA, to design very large orbital habitats for up to 1 million people, all constructed in space and all rotating to provide artificial gravity inside. And these came in 3 flavors. There's the Stanford Torus, which got the majority of design energy there on the left, and the Bernal Sphere, which was an alternate design for the same amount of people, and also the O'Neill Cylinder, which was the most advanced but really least detailed habitat design. That was a structure for millions of people that could be up to 5 miles long. And in particular, this book focuses on a 1975 design workshop, a so-called summer study at the NASA Ames Research Center in Silicon Valley. And these summer studies took place throughout the 1970s and 1980s at NASA Ames. And they were always opportunities to think big and think deeply about large-scale, long-term plans for NASA's future. dealt with topics like the search for extraterrestrial intelligence, nanotechnology, and space manufacturing. The 1975 summer study was about building these cities in space. And so this study brought together architects and urban planners to work alongside space scientists and engineers, along with two painters, Don Davis and Rick Guidice. The two painters made a series of 13 renderings for the project, interiors and exteriors, that have had a lasting influence on a number of fields since then. My book is in many ways a close reading of these paintings, drawing out their connections to the more mainstream history of spatial practice and visual culture, as well as to further out fringes like the counterculture, political separatism, and science fiction fandom. So in this book talk, what I'll try to do is summarize the threads that run through these chapters and the way in which they build the book's stories and arguments. So here's Davis and Guidice today. I was able to visit both of them in their respective studios, both in California, to gain access to some of their archives and sketches and to interview them and hear their stories about the work. And they have this interesting series of complex interconnected backgrounds. Don Davis there on the left got his start doing illustration for what was then a new scientific field called planetary science. So he was one of the first people who was really engaged with imagining what it would be like to be on other worlds that hadn't had human visitors yet. And Rick Guidice was trained as an architect and went on to do a lot of commercial illustration and graphic arts. He, one of his later projects that is probably familiar to a lot of you is he got to do the covers for a lot of the famous Atari video game cartridges. And they both painted covers for science fiction books as well. The 1975 summer study was led by a Princeton physicist, Dr. Gerard O'Neill. For O'Neill, in his own story about this project, the work began in 1969 when he asked his freshman physics students, quote, "Is the surface of a planet really the right place for an expanding technological civilization?" The arguments in the book are partly based on opening up the terms presented by O'Neill. What is important about the nature of surfaces, planets, places, expansion, technology, and of course that very fraught term, civilization. And there's this kind of spatial complexity built into this project right from the beginning. When O'Neill had been assigned in 1969 to teach this introductory course in physics, the first thing he did was to make a course within the course, a space within a space, where he reckoned that, as he put it, the more gifted students could work on special topics directly with him. And he hoped that by answering questions like the one he posed about surfaces and planets and civilization, this subset of students could address problems that were facing, again, as he put it, quote, all of humanity. And this was at a time in the late 1960s, as protests against the Vietnam War were reaching a high watermark, when engineering and technology were getting a bad rap. And so their answer to this question was predictably no. The surfaces of planets, O'Neill and his students decided, were not the best places for expanding technological civilization. But instead of bringing the notions of expansion or technology into play and into question, their next step was to focus on surfaces. They proposed to design new surfaces in space, away from planets, totally defined by technology, wrapped up and closed around themselves. And these surfaces would form the basis for new landscapes, cities, and buildings inside. And this idea of a sequestered group of technicians producing a closed world or walled garden has particular resonance in design culture today, as again, the nature of spaces, virtual and actual, that are designed aligns with the nature of the spaces that those spaces are designed in. So to quote my friend, the anthropologist Lisa Messeri, who's paraphrasing Donna Haraway, it matters what spaces make spaces. So here's Apple's new headquarters, recently completed, also of course in Silicon Valley. Besides the formal resonance here, it's important to remember that what structures like this have in common is that they're designed to provide, as far as possible, all the supplies and amenities an inhabitant might need. So in the culture of the technology campus, like the space habitat, you'd never have to leave. And this is kind of resonates with the way Apple creates a sort of ecosystem of products too, that you'd use Apple services on Apple devices as much as possible, and they stay within the kind of ecosystem that they design. And as a side note about their headquarters, one thing that they forgot to include in the space was childcare. Famously, when it opened, it had a huge gym and a climbing wall, had one of the largest parking garages in California, several cafeterias, and no daycare on site. So the designers of the Stanford Torus presumably remembered to include that. And here's the new Google headquarters, under construction now, coincidentally, right across the street from the NASA Ames Research Center, where the 1975 summer study took place. This rendering reenacts almost point for point with the running paths, cafes, and terraces made of reconfigurable prefab modules, Rick Guidice's painting of the Stanford Torus interior. So what is the nature of this wraparound surface, and what are the qualities of the spaces that those surfaces create and enclose? When the human inhabitation of outer space was made to seem, for the first time, technically possible, thanks to Konstantin Tsiolkovsky's rocket equation in the late 19th century, scientists supposed that free fall in orbital space would allow new ways of living to be experimented with. In this drawing of Tsiolkovsky's, you can see tiny figures floating, each one with a different body orientation, a different up and down. The hope is that these new spatial relationships would engender new social and political relationships, which of course is a claim we hear quite often in architecture. By the time the International Space Station was designed, space scientists had begun to realize that different orientations in free fall produce confusion, especially among a crew that had so many different cultural and geographic origins. So in order to produce more spatial unity, life within the station follows an agreed-on shared set of coordinates that the crew nominally stays oriented to. So everyone goes about their business whenever possible with their feet pointed down towards the deck. And this is based on nautical terminology, of course. And the station itself continually adjusts its own orientation to the Earth's surface with gyroscopes, so that their down is always the same as our down here on Earth, pointing to the center of the planet. Even though the station orbits 200 miles above us, it's almost as if it were just a very tall building. As humans can't live in zero gravity for long periods of time, besides the radiation that space exposes our bodies to, human bone strength, eyesight, and muscle mass starts to degrade after just a few weeks in freefall. So the habitats designed for the 1975 summer study would all rotate to provide artificial gravity inside through centrifugal force. This has some interesting spatial consequences too. The overall form of the structures would have to have rotational symmetry, so hence the spheres, toruses, and cylinders. But inside, there would be no horizon falling away from the observer. Instead, the distant territory tips up and presents itself to you in plan or aerial view by the time it is directly overhead. On Earth, we perceive the land to be flat on average, with each of us sharing the same surface, though of course that's not the whole story. In the summer study habitats, much smaller than planets, it might seem clear that each person was inhabiting their own individual patch of orientation and geometry, with their heads pointed towards a common center and their feet pointed outward to the blank Poche vacuum void of outer space. And some researchers on the NASA team thought that these conditions might contribute to something they call Solecism Syndrome. This is a retreat into the self, as a person could not avoid dealing with the fact that their entire world was constructed artifacts. In other complementary media, though, entertainment, film, video games, and experiments in cartography, like this one from the British design studio Berg, designers have speculated this mode of perception, instead of causing stress, might feel like a kind of superpower, the ability to see the near and the far at the same time. And this project came out less than a year before the design work on the movie Inception started. So there's a lot of talk and speculation about how this may have influenced the way the city folds in the movie Inception. And there's a precedence for this kind of spatial superpower in the history of architecture, especially in didactic structures like cycloramas and panoramas, making complex environments comprehensible. And in some of the large spaces in visionary neoclassicism that surround the inhabitant of the space with collected knowledge, in the case of Boulet's library shown here, light, or as in the case of Boulet's Tomb for Newton, a model of the cosmos itself. And the new surfaces in the 1975 summer study project are also related to another long lineage in architecture and urban design, the desire to get away from the old default pre-existing ground plane and build new artificial ground in the sky. So whether we're talking about the private ground enabled by the skyscrapers that Rem Koolhaas wrote about in Delirious New York, or it's the public ground of roof gardens, podiums, skywalks, and flyovers of Corbusian urbanism in the radiant city, these projects share the same critique of original urban ground, that it was crowded, dirty, dark, and that there was too little of it left to go around. So in the literature and art made for the summer study project, we can see that all the same things that critics were saying about the 20th century city are now expanded in scope and used to critique the entire planet Earth itself. And in North American popular culture and science fiction from this era, there was a growing sense that Earth was too small, that there was not enough room for people to live in, not enough resources, and not enough space to throw away pollution and garbage. In 1972, the private think tank, the Club of Rome, published a popular science fiction book that said as much. Titled Limits to Growth, it was a bestseller that was widely read and discussed. And in 1973, the popular science fiction film based on a novel titled Make Room, speculated that Earth would soon get so overcrowded that everyone would need to eat Soylent Green, which is made of people. Spoiler alert. So Le Corbusier's solution to congestion is to create a new urban condition in which, as he says, quote, the whole city is a park built on artificial ground. Then Gerard O'Neill's team would design a case where whole new worlds could be parks and thereby alleviate Earth's overcrowding. But as the designers of parks well know, artificial ground needs maintenance. Famously, the old new ground of the High Line was originally intended by the park's designers, field operations with Deutsche Renfro, to be treated as a found condition that would then be added to enable human occupation. When its survey began, though, it uncovered the old artificial ground, and they discovered that it had to be almost completely scraped away and replaced before the new park could be built. With deferred maintenance and neglect, had left the 100-year-old elevated rail bed to rot and rust. And new ground also depends on extraction. Central Park used guano mined from South America and night soil from New Jersey in order to make the land fertile enough to support new meadows and trees, which work also included, by the way, the displacement of communities of native and formerly enslaved people. In O'Neill's project, first the moon and eventually the entire asteroid belt would be strip mined to build more and more new ground in the sky. As artist and theorist Lisa Lepard says, and I'm paraphrasing here, the existence of a new hill or structure in one place implies the existence of a new hole or void someplace else. In Larry Niven's 1970 book, Ringworld, a multiple award-winning science fiction novel that was well known by both of the summer study painters, explorers discover a spinning artificial habitat as large as a planet's orbit, made of artificial ground with a biosphere on the inside. The surface of the ring is sculpted in low relief, so that everywhere there is a dent on the underside, it corresponds to a mountain above. To solve some of the obvious problems here, Niven had to invent a huge system of pumps and pipes for the sequel books that would return eroded material to the high ground over a period of centuries. There's a scene in the philosophy documentary, Examined Life, with philosopher Judith Butler taking a walk in San Francisco with disability theorist and artist Sonora Taylor. Butler is on foot wearing shoes, and Taylor is using a motorized wheelchair. They're having a conversation about how the design of certain kinds of spaces and surfaces invites some people to use them, and how the design of other spaces and surfaces can exclude them. This inclusion and exclusion can be a result of the way a space is formed, and it can be a result of the way the space is operated, organized, and controlled. And architects know this lesson, or they well should, but in the history of human spaceflight, there's a particular story that illustrates this principle. The third crew of the American Space Station Skylab, designated Skylab 4, found that the minute-by-minute checklist of tasks from ground control was too much for them to handle. The close coordination between the station and the ground left little flexibility, especially since the large size and complexity of the space inside Skylab was not taken into account by the mission planners. The crew pushed back and took some unscheduled time off to regain their bearings, and to look out the window near the galley kitchen dining area that designer Raymond Loewy had specified for them. Order was restored and the schedule adjusted, but for whatever reason, no one in this crew ever got the chance to fly into space again. their existence as astronauts able to access space have been redesigned and redefined. And in NASA's official report from the 1975 summer study, a similar story lies buried. The section on urban planning in the habitat specifies the amount of square footage that should be given over to the different functions inside. The urban planners collected data on things like public space from world cities. They looked at the average square footage of the low end, and then they decided to cut this number almost in half. The habitats would have agricultural areas, they reasoned, and so that space would also be available to residents for recreation. Meanwhile, the agriculturalists, in a room presumably right down the hall during the summer study, in their section of the report, are expecting that the farms that they're designing could produce twice the world's record yield for crops like tomatoes all year round, but only if the spaces could get 24-hour sunlight, constant high humidity and heat, and a specialized atmosphere supercharged with carbon dioxide, which sounds increasingly like our atmosphere here on Earth today. The spaces implicitly include and exclude certain types of subjects within them that are designed to be optimized. A plant heaven is a human hell, even though we share many of the same spaces here on Earth. And indeed, the design of spaces and operations within these habitats would have to accommodate many kinds of non-humans as well, including chickens, rabbits, and fish. The non-human animals in the Stanford forest would outnumber the human 35 to 1. And this brings up the question again of who exactly the space is designed for. But this has always been the case. Non-human animals were the first Earthlings to travel into space. This crew, for example, flew into space 2 years before Yuri Gagarin's historic flight. So design here is as much about systems as it is about objects. And as the Stanford Torus details were specified, the engineers used network and directed graph diagrams to keep track of the flows of matter and energy within the habitat. And this impulse to understand and control through the means of these diagrams was a symptom of an overall obsession with systems during this period. The basis for the Club of Rome's work in their book Limits to Growth had been to diagram human relationships with the planet Earth using these same methods, which had become the model for their computer program that predicted social and environmental collapse within 100 years. Gerard O'Neill offered a direct rebuke to the Club of Rome when he testified before Congress in 1975 that any, quote, limits to growth would be un-American, and that his project of space settlement would, in contrast, offer plenty of, quote, room for growth. The ultimate end goal, O'Neill wrote in his book on the project, was to create as much new surface area as 3,000 Earths, but only after strip mining the moon and disassembling the entire asteroid belt to build these new habitats. He also offered to Congress and to his book audience an indirect rebuke to the work of biologist Rachel Carson and her millions of readers when he suggested that the space settlement could be refuges for birds endangered by the pesticide poisoning that she wrote about in her best-selling influential 1962 book, Silent Spring. Of course, really the founding document of the contemporary environmental movement. O'Neill noted in his own book that no pesticides would be necessary in these habitats because they would be careful to avoid importing pests in the first place. And these fears and hopes about the future are related to the same impulses that drive science fiction as a cultural mode. O'Neill himself was always quick to dismiss any direct connection between his work and science fiction. He insisted on the plausibility of his proposals that were, he always used this phrase, possible within the bounds of current technology. So that would be the current technology in the mid-1970s. But the two painters, on the other hand, were both avid readers and watchers of science fiction. And this influence is evident in the architecture and space making shown in the renderings for O'Neill. Rick Guidice said in an interview that when he got the commission to paint the O'Neill cylinder, he immediately thought of Arthur C. Clarke's popular award-winning book, Rendezvous with Rama, which describes an equally huge spinning cylindrical habitat built by a lost alien civilization. And again, Larry Niven's Ringworld, essentially a giant-scaled Stanford torus, also influenced Don Davis's visualizations of the summer study team's work. Davis is a friend of Niven's, and he had made this painting Niven's ring in 1973, which Niven used on the cover of a 1981 edition of the book. So what you're seeing is the relatively flat surface of the ring swooping in the distance and becoming like an arch overhead. So again, the landscape curving up and around you. And this relationship between science fiction, classic utopianism, architecture, space science, apocalypse, and popular culture are the subject of chapter 5 in my book. These connections, especially in the 1970s, is evident in that era's visual culture, are deep and complicated. The summer study work represents an important nodal point where these fields come together. The Club of Rome's graphs of Earth's rising population and industrial capacity are an almost perfect echo of NASA's original logo, two converging lines moving up and to the right. And there are other graphs showing a hypothetical steady state planet in which growth types level out, recalls NASA's updated typographic logo from 1975, the worm logo there in the center, that they would later scrap and return back to the so-called meatball logo, the classic circular logo. But in that worm logo, these smooth curved lines wrapping back on themselves also prefigure the kind of closed world of Star Wars' Death Star. And this is the kind of representation or manifestation of the fear that a closed and controlled world that the Club of Rome was calling and advocating for would be something that was totalitarian and even nightmarish. While on the other hand, the alternating slopes and plateaus in the oblique architecture of Claude Perron and Paul Virilio at the bottom left hint that inhabiting that transitional surface might be another way to question and displace existing spatial and social norms. So the next set of arguments in the book pushes these connections further and looks at two interrelated critical concepts that both deal with issues of very large scale. One from science fiction studies, the so-called big dumb object, is a way to describe the overwhelmingly sublime effects of massive structures whose origin and purpose seem unclear, but also seem to be the key to whole new worlds. So Arthur C. Clarke's Rama and Larry Niven's Ringworld are the kind of classic big dumb objects. The architectural category of the megastructure, on the other hand, openly invites participation, engagement, and interaction, but this time all on the user's terms. So if the big dumb object implies that can change me, then the megastructure says I can change that to the user. Both are transformative, but in complementary ways. And in large-scale structures like the space settlement, both design approaches are necessary for mitigating what theorist Frederick Jameson calls, following architecture critic and Pareto Tafori, quote, the dialectic of identity and difference. And in the end, it's ultimately these paintings themselves that act in culture, if not to resolve all of these contradictions, and at least to uneasily settle some of the arguments and conflicts between the different disciplines and communities that have been involved in the project. The paintings are often deliberate provocations made by the artist to intentionally raise more questions than they answer about the possibilities for life inside these spaces. Don Davis, for example, talking about this painting, mentions that he really wanted to sort of push the limits of what he expects people to think would be possible in these new worlds. So it's a deliberate provocation. And the public constituencies built around these paintings, encompassing everyone who reacts to that provocation, pro or con. These paintings have been in the public domain since they were made, but this book is the first time they're all collected together in print. And again, thanks to the Graham Foundation, we were able to publish in the book's appendix many of the sketches that the artists made for the projects and other related work. And I think that one thing I love about these sketches is that they foreground the fact that these artifacts were made for really specific purposes by specific people with unique backgrounds. And those people were in very specific, sometimes closed and singular, sometimes open and interconnected spaces, disciplinary and otherwise. Like this drawing, for example, could be made nowhere else but in California. And in these sketches, you can see the literal construction process of the spaces happen from the perspectival bones on up. The surfaces and scales were carefully calculated by the artist before all the persuasive mood, atmosphere, and aesthetics were added. And they were made in literal correspondence with folks from different fields. So here's the drawing that Gerard O'Neill himself made and mailed to Don Davis. It's a diagram showing elevations in the end caps of the O'Neill cylinder, but it's also a cut and fold space settlement model that Don photocopied and then assembled to get an idea of the doubly curved geometry to define this space. So again, in a document like this, you can see the physicist and engineer acting almost as a landscape architect or regional planner as he's designing the world inside this enclosure. And tracing this process also reveals how some of the design choices evolved. An early version of this painting included a more normative, basic log cabin. But after O'Neill sent a note to Don Davis asking for something more like a geodesic dome or vessel, Davis compromised between the two and painted the cabin as a modified lunar lander from the Apollo project. And the sketches made by project architect Patrick Hill showed the influence not only of Moshe Safdie's Habitat project, but of other work that Safdie has done with terraces and artificial ground over service space, like Baltimore Zone, Cold Spring, Newtown. And again, these seemingly superficial formal resemblances reveal deeper structural similarities between these projects for the future inhabitation of outer space and the history of projected urban space here on Earth. Thank you. Stop the screen share. So, Margaret, how do you want to handle any Q&A or any discussion?
Sorry about that. It was taking me a minute to unmute. I will read some of the questions and you can go ahead and answer. Real quick, I just want to remind everyone, if you need AIA or ASLA credits, the link has been resent in the chat box. Please fill that out. And we'll start with the first question. After the NASA summer study in the 70s, has there been any other study of similar proportion done on space settlement design?
Not really at this scale, I think. There's always, these things pop up periodically in visual culture, and people make renderings for newer projects, but this was really a kind of a first time and really still the only time that I think all these different disciplines were involved. And that's the key to this project, is that they were really reaching out to architecture and design, even art, sociologists were there, anthropologists, so that even if the perspectives didn't mesh, as in the story about the agriculturalists and the urban designers, at least people were there at the table. At least people from different disciplines were there at the table. I think projects that we've seen since then haven't had that same large, ambitious scale, and they haven't had that same kind of openness to really bringing all kinds of people to the design table to contribute.
Okay, thank you. And our next question we had was, I wonder if Davis, I'm going to mispronounce his name, Guidice or Guidice, and NASA were historically aware of Frederick Keisler's Endless House Project, 1950 to 1960, as they developed their designs.
Could you repeat that? I lost a little bit towards the end there, Margaret.
Sure. He was wondering if NASA were also historically aware of Frederick Keisler's Endless House Project as they developed their designs.
Oh, yeah, I don't think so. That is a neat kind of other example of like architecture turning in on itself and wrapping around itself, right? That Rick Guidice, who's trained as an architect, one of the two painters, he name checks really Moshe Safdie and other kind of megastructural work from that period. Don Davis, in talking to him about architecture, he was really shy about it, surprisingly, and he kept saying, "Oh, as an architect, as somebody who works in architecture, you're probably not very interested in these buildings I put inside this thing." And the buildings he painted and effectively designed are really cool and interesting kind of translations of California Googie architecture, of kind of, you know, call it a kind of folk futurism. But he really wasn't aware too much of architectural history or precedent. He was just doing things he found interesting. And he, you know, he was the person who's into visual culture generally, so he would look through magazines every now and then, but he wasn't citing any specific precedent. I would really tie it to, you know, kind of roadside architecture and pop futurism from California in the 60s and 70s, his work. Definitely not anything as obscure directly as Kiefler's work.
Okay, thank you. And let's see. Another question here. How did we figure out the balance of gravity, or how did they figure the balance of gravity in the torus? Is there a system to redistribute the mass?
Basically, you use water. In the torus, in a lot of the paintings of the Stanford torus, there's a stream running down the middle. And one of the cool things that they realized is that if you just sort of let water flow, it will balance out the spin on its own. I think there was an issue with the stability of, and since it's a wheel, it tends to sort of be pretty stable on its own anyway. The Stanford torus, at least, giant bicycle wheel. There, I've seen, and I'm not a physicist, of course, but I've seen and read physicists since this project, you know, in the contemporary era, talk about how the spinning cylinder of the huge O'Neill cylinder would be much more harder to stabilize because it would tend to kind of skew this way as it's spun. Any little imbalance at the far ends would throw things out of whack. So they, in O'Neill's original project, they tethered them together. But the torus is pretty stable, especially if you put water in there, that'll redistribute the mass.
And I thought this one was interesting. Do you think NASA should include architects for their next application or for their next class of astronaut applications?
Yeah, absolutely, of course. I think that you know, the best object lesson related to NASA's inclusion or exclusion of architects is the story about Raymond Loewy pointing out that they needed a window next to the kitchen in Skylab. That the engineers had said, and this is maybe a little bit legendary of the story. I don't know the actual facts of this dialogue, but the engineers at the time designing Skylab, America's first big space station, would say, well, what do they need a window for? They have the best telescope ever made here that they could look through. They have all these ways to gather information. They can see, you know, details that the human eye on the surface of the Earth would otherwise not be able to see. What do they need to look out a window for? And Raymond Loewy says, what are they going to do while they're eating dinner? You know, everybody likes to look out a window while they're having dinner. So he made the case to, you know, which is a non-trivial thing, to punch a hole in a space station and deal with, as we know, as people who work in architecture know, all the now tricky issues about detailing a window, an aperture in that thing. So he made the case for it, and they did it.
Sorry, it looks like a lot of questions are coming in. Seeing a bridge shown in one of the paintings made me wonder if you or the designers you speak of considered the question of whether or not one should design out the conflicts humans are constantly working against in nature. We design bridges to overcome obstacles of terrain. We apply sunscreen to the danger of exposure of the sun. Do we try to eliminate these, or is this struggle an essential part of human habitation?
The bridge in the kind of they call it Davis. Even Don Davis calls it the Bay Area painting. The bridge in that painting is a really neat provocation, and I think I didn't get a chance to ask Don Davis specifically about this, but I think one of the many questions it raises is exactly that one, because bridges are, like, we build bridges because of pre-existing conditions. We come and encounter an obstacle in the landscape, and we want to create something for humans to use to overcome that obstacle. But as your question points out, if you're designing the obstacle in the first place, there's something really weird about designing the problem and then designing the solution to the problem. And yeah, I think that's a paradox and even a provocation on Don Davis's part to put that bridge in. And another sort of buried joke about the bridge, or another thing the bridge raises, is a line that comes up in O'Neill's writing as a physicist about the project a lot. In a couple of articles and in his book, he says that the physics problem of designing these large spinning habitats is pretty easy in engineering terms. He calls it a suspension bridge with no endpoint. So in some sense, the habitats themselves are bridges too. They are that same kind of thing where there's an obstacle in nature, a found condition that humans can't live in outer space. So we create this large structure that overcomes that obstacle for human use. And so that idea, that paradox of designing conflict and designing against conflict is really embodied in that bridge. I'm glad somebody asked about that. I think it does raise this question about how essential conflict or struggle, as your question puts very well, how essential conflict or struggle is to human habitation, human existence, where we need resistance and friction in the landscapes we build in order to be fully human. I think that's exactly the bigger issue.
Great. And next question, could you speculate that the space-facing views could be more of valuable real estate versus the inner views, or vice versa?
The views thing is tough too. I think I'd turn that back around and say that well, on the one hand, the views are a problem, because if you're seeing directly out a window into open space for a long period of time, unless that window is very, very thick, then you've got a problem, because you're directly exposed to cosmic radiation and solar radiation when there's solar storms. So you don't want to direct it in the space station, Skylab. Sure, you want a window because you're only up there for a few weeks and you can look out a window and you'll be fine. But in a place you're living full time in, you don't want a direct view to the outside, because you're seeing cosmic rays hitting your brain and messing up your DNA, or worse. So the views would be, and there are all kinds of neat, complicated diagrams showing how solar incoming sunlight would be reflected in to light the space. So there's no direct view. They use a complicated set of mirrors and baffles to get around the direct view. But I'd say, in terms of valuable real estate, that raises all kinds of questions that aren't really addressed anywhere in the study, which is, bigger things like access to housing. If you're there, do you have, is there a social hierarchy? Is there an economic hierarchy inside these habitats? Do we design the political or economic system, and does it correspond to a spatial system the way that those of us who work in architecture are all too aware can happen? And this is the breakdown of, I think, I'd say Corbusian urbanism, is that Corbusier imagined a flat society, but he created hierarchical space. So the flat society never came, but the hierarchical space he created is everywhere around us. So our hierarchical society maps to the hierarchical space that he made. Right, one of the things that happens. I think that would happen unless society itself were designed in a different way too, within the habitats. If we're able to build new ground, should we also build new political and economic systems that guarantee access to that ground and to all the other resources that we need to survive? I'd add a question to your question, Jonathan, and say, remember that gravity gets lighter the higher you go. So with the upper floors of a building that in which you'd weigh a little less, would it be valuable to be high because you'd only weigh 90% of your weight that you would experience in the lower level? So that's another way that space here can create or map onto social hierarchies.
Great, thank you. This one's a little bit long. A lot of contemporary art from Rachel Kushner's novel Flamethrowers to shows like the Deuce are looking back at the 70s. Do you think of the 70s as a moment that preceded the sort of pure, oh wait, this isn't the question I was trying, nope, okay. you think of the 70s as a moment that preceded the sort of pure capitalism that has persisted to pre-COVID today? And where do you think the current capitalism plays in contemporary summer study-esque projects?
Yeah, I think the 70s are really fascinating for a number of reasons. There was this like overlap of apocalyptic scenarios. You know, people still weren't over the Cold War, and fears about nuclear apocalypse were still, you know, very much in play in culture. And at the same time, you started to have all this sort of beginnings of an ecological consciousness coming to the surface too. I think that, you know, that's really present in Rachel Carson and the Club of Rome, the two examples that I cite, where popular culture was being made aware that, hey, we can't just keep using resources. We as humanity, we as Western capitalism, say, can't keep using resources at the rate we've been using them. We can't keep treating resources and aspects of our world in the way we've been treating them, or else we'll have another kind of apocalypse floating over our head. And on top of all that, there's the energy crisis of 1972 and 73. So, of course, the OPEC oil crisis and gas prices and energy prices suddenly spiked off the chart. That was a real wake-up call to, again, Western capitalism, that this show isn't going to go on the same way forever. So that's why again, I'm always fascinated by that line that's sort of up and to the right. This assumption that expansion could and should occur indefinitely. That was what this project was designed to support. This being the 1975 project. It was designed to allow that growth curve to just keep continuing. And now, of course, we see that growth curve everywhere. Every day, I reload that Johns Hopkins website, and we see that growth curve. What's going up is not, you know, GDP. So this is one of many. You know, it's almost like apocalypse aesthetics, you know, is in play, I think, in the 1970s, and very much, you know, in play here in the 2020s as we find ourselves.
Okay. And are you aware of any architecture practice studying design for a free-floating space settlement now?
Jeff Bezos' company, Blue Origin, has kind of resuscitated all these ideas, or at least Bezos himself has sort of come out in favor of like a redux of this 1975 O'Neill project. And there's a direct connection there with Jeff Bezos. When he was a student at Princeton, he didn't take any of Gerard O'Neill's classes, but Gerard O'Neill was kind of this semi-famous figure by the time Bezos was there in the 1980s and 90s. And Bezos would go and attend talks. He would basically audit like lectures from Gerard O'Neill. And he was a fan. He started like clubs on campus about this stuff, about space settlements. And so Bezos is now, I shouldn't say, but I know he had a call out recently for architects to come and work for Blue Origin. So yes, I think there are architects working on these kinds of projects. And of course, at University of Houston in Texas, there's a whole space architecture program, and a bunch of other people have been working on, you know, I think more from a technical side mostly, the idea of architecture as like human habitable space in space. One exception to the technical side is Michael Morris and the late Yoshiko Sato, who had a space architecture course at Columbia for several years that Michael Morris still teaches that now at Pratt.
Okay. I was listening to a podcast not too long ago that was talking about something along these lines, and I think it was Big out of New York who was working on it as well, but I don't.
Yeah, it wouldn't take long for Bjarke Ingels to get involved too. He probably has designs for space settlements in a drawer somewhere. I know he's doing work on Mars. He's doing work that
That's what it was.
the Saudis have commissioned about kind of rehearsing for Mars settlements, and so is, of course, Elon Musk has have sketches at least for Mars cities. But yeah, I mean, you bet that the Ark is involved.
Mm-hmm. And lastly, are Davis and Guidice still alive?
Yeah, very much. Yeah, yeah. I got to visit both of them in around 5 years ago now. But Rick Guidice was still practicing as an architect for a number of years up until really recently. I got to visit his studio and see some really cool stuff that some of it made it into the book. And John Davis lived in Palm Springs for several years, and he recently moved to Joshua Tree. And he still makes art and still has a great Facebook page. His personal Facebook page is just great. He just muses about all kinds of astronomical subjects, and he's a sort of amateur astronomer as well. They're very much alive and doing interesting work too.
Okay, that's great. I don't see any more questions that have trickled in, so if there's nothing else, thank you, Fred, very much for your flexibility and willingness to do this online. It was great, and I certainly enjoyed it.
Thanks, you all. Thanks a lot.
All right. Thank you.